Welcome to this new RICOMET session organized as an expert consultation by the SHARE platform, the Horizon 2020 RadoNorm project, which started yesterday, and the IAEA. We are here extremely glad that we could gather this group of high-level experts from different parts of the world, and we are very grateful for them taking the time to share their knowledge, to reflect on how citizen science can support radon measurement and, most importantly, mitigation. This session will last for 2 hours, including a short 5-minute break in the middle. I am Meritxell Martell. I'm an environmental scientist. I am the SHARE secretary and also the director of Merians, an environmental strategic consultancy based in Barcelona. With me, Joke Kennens. She is the moderator of the chat area. She's a PhD student from Leuven University and SSH-SHARE, and her research examines bottom-up citizen science after Fukushima. So she's an expert as well. You can use the chat area to ask questions, and you may want to share your questions with all the participants by using the all panelists and all attendees also. Thank you to all the participants, around 100 registrants joining us from different parts of the world and different time zones. The session is being recorded and will be available from the SHARE website. Citizen science has already been successfully used in many countries to collect data on radon. This expert consultation is part of the RadoNorm project, and we have asked our discussants, high-level experts from research and practice related to either citizen science and or radon, to present different initiatives. We would like to explore with them what is the potential for citizen science to support effective radon measurement and, most importantly, mitigation. So we have in the session today 7 speakers: Professor Muki Haklay from UCL and the European Citizen Science Association, Dr. Camille Allonsius from the University of Antwerp, Mrs. Stephanie Long from the Environmental Protection Agency of Ireland, Professor Konstantin Kovler from Israel Institute of Technology and Taking Citizen Science to School Research Center in Israel, Dr. Aaron Godarzi, Carbon Cancer Institute at the University of Calgary in Canada. Good morning for you, Aaron. Dr. Bernard Collignon from the Scientific and Technical Center for Building in France, and Dr. José Luis Gutiérrez Villanueva, Secretary of the European Radon Association. Each of the speakers will have 10 minutes for the presentation, and then we will open a Q&A session after that. We also have with us Dr. Mandy Birschwilks, representing the RadoNorm project and BFS, and Dr. Olga Herman from the IAEA to close the session. So we welcome our first speaker, Professor Muki Haklay, who is Professor of Geographic Information Science at the University College London and co-director of UCL Extreme Citizen Science Group and the co-vice chair of the European Citizen Science Association. He's going to set the scene on what is citizen science, will provide an overview of different forms of citizen science, and will explain the work undertaken by the European Citizen Science Association. So please, Muki, the floor is yours. If you want to unmute yourself and share the presentation with us, that would be great. Thank you. You can unmute yourself.
Yes, thank you very much for starting the session. What I'm going to do in the next 10 minutes, I'm going to quickly cover what is citizen science, because as we will see, it's a very wide area with a lot of different understanding of it. So we'll start with talking a little bit about the growth of citizen science, look at different aspects of citizen science today. So what kind of activities are included, modes of participation, relationship between scientists and the public, and the role of technology. We look also at the characteristic of how you decide what is citizen science, and also what are the best practices. So citizen science in the past decade, the awareness to it grown rapidly, and we can see it's, for example, in the number of publications, that's just up to 2015, and we're actually seeing a really rapid growth in the publication. Oops, sorry. Sorry. Let me share again. Okay, just a second. To reopen the presentation. So let me do that. To apologize. Decided to open it.
Are you getting there, or do you need
yeah, I hope so. For some reason, PowerPoint just decided to close down. So let me just put it up again, sorry. Okay, we're up again. Yeah, let me share it now. Okay, and yeah. Okay. So we were talking about the growth of citizen science in the past decade. And what we can say about the growth of citizen science also, that there are two underlying trends. A lot of time people talk about technology as the reason for the growth that we are seeing in citizen science. But actually we also have to remember that we have a rapid increase in education across the world, with more and more people getting into higher education and securing higher education degrees, which means that the population that understands science is much bigger. Now, when we try to understand citizen science, we can think about different areas that are included in citizen science. The first of this area is the topic where we have a long-running project that has been running areas where citizen science was active for a long time, for example, in ecology and observation, or in meteorology, where the public participated in observation for over 150 years, but there are changes due to the technology. So for example, relevant to the topic of our conversation is this example of the community collaborative rain, hail, and snow network, where people are getting used to report about precipitation that they see, and they are using a computer system to report it back to meteorological offices. But the advantage of that is that when there is an extreme event, they are in place and they know how to report an event. And this network, for example, already helped in mitigating flash floods. The next area of citizen science that we look at is something called citizen cyber science, which is a term that is used to describe things that can only happen with the internet and with computers. So for example, something that is relevant is volunteer computing. When you don't have enough computing power and you want to access to abilities like supercomputers, you can access either people's mobile phone while they're not using them and being charged at home, or the ability of their computer while they're not using them. And that allows you to run all sorts of complex modeling, and people are really willing to participate. And it's also increased awareness about the topic at the same time, because there is a screensaver or something similar to that. The next type is something called volunteer thinking. And that's when you ask the public to use their cognitive ability. So for example, this is from the ECSA Institute in Austria, where they engage a lot of people in classifying land use from satellite. and enabling to discover, for example, types of soil or type of vegetation that are growing in different places. There is also ability of using this form to do passive sensing. So instead of trying to set all the aspects of computing systems that are connected to sensors, you send to people just the sensors. So this is an example from earthquake where people are being given an accelerometer, it's connected to the computer, and then it can report when there are vibrations that are important to observe. And you can think about reducing the cost of sensors and reducing the aspects of communication and storage. The last type, which is something that I've been involved a lot on, is community science. In community science, we have things like participatory sensing, where we use the ability of people's mobile phone, for example, to deal with noise or to deal with, when people are around, and it can record the location and abilities. And the reason that it's called participatory sensing is that people are involved in both the decision where to record, and they are having more involvement in the process of how to record the information. The next type is also relevant. It's the DIY science, where people can construct their own sensors, and then they have more agency and ability to control it. So a good example is the flood network, where you have instead of the way that Environment Agency will do it with complexity of finding a public space, of communication and so on, people put flood gauges at the end of their garden using their home Wi-Fi, solving the problem. And also the problem of energy is being solved by the sensor beeping and asking people to change their batteries, something that it's much more complex for a public authority to do. And then there is civic science, when those type of activities are also integrated into dealing with environmental problems that communities are concerned with. So Public Lab is a good example of an organization that is doing that. The type of participation in citizen science can be described in different levels. So we can think about this volunteer computing as level 1, where mostly we ask people to give resources and not to be involved very much. The level 2, we ask them to involve in cognitive effort. In level 3, they are kind of defining also the problem, but still there is a strong element of scientific control over the project. And in extreme citizen science, we just reached the end of extremities of citizen science, and the whole process is actually happening by members of the community and just with help of scientists. And it's important that in each, that all these levels are valid, so not one of them better than the other. There are reasons for people to participate in each one of them. So to kind of progress with citizen science, you can think about how to do citizen science well. And for that, the European Citizen Science Association, which is now existing for over 8 years since the early beginning, established things like the ECSA 10 principle that I was saying what should be happening in different citizen science. So for example, projects should have genuine scientific outcome. Now that can be for administration or it can be a scientific paper, but it's something that is important. And also issues like access to data and so on. This does not solve the problem of deciding what is and what isn't citizen science, which is a common problem that is now emerging with different funders and organizations. And this area of what is citizen science, so someone watching birds and reporting to scientists, very clear. Someone being employed just to take a survey for the Environment Agency is again a not citizen science, but what happened in the middle? To do that, we actually carried out a really detailed study last year of understanding what is and what isn't citizen science. We broke it into core concept, disciplinary aspect, because there are differences between public health and environment. We looked at how the leadership is influencing the project, and financial aspects, and also aspect of data and knowledge. You can find this document open on Zenodo. If you look for the ECSA characteristic of citizen science, and in particular, there is a document where you have the explanation that might help you to understand what is and what isn't citizen science according to your area. So we see that it's grown in size and aspects. There is a growing body of knowledge, and networks like ECSA, for example, is a place where you can share the knowledge and learn more about it and get support. And that's me finishing. Sorry for the problem.
Thank you very much, Professor Haklay. That was very useful to have this overview of how difficult it is actually to define what citizen science is. So thanks a lot. And now we move to a specific example provided by Dr. Camille Allonsius. She works as research manager at the Global Change Ecology Excellence Center in the University of Antwerp. And Dr. Allonsius is working on the large-scale citizen science projects. So she's going to talk about the specific initiatives of how citizens were involved in the Curious Noses initiative, success factors, and lessons learned from these projects. So if you want Dr. Allonsius to share the presentation and unmute yourself.
Can you see my screen?
Thank you. Yes.
Okay. So hi everyone.
Thank you.
So yeah, I'm Camille Allonsius, and I will tell you a bit more about our Curieuze Neuzen project in Dutch and Curious Noses in English. So firstly, I will tell you a bit more about why we organized the citizen science project on air quality. So the European Union sets limits for the concentrations of nitrogen dioxide in the air. It's one of the main indicators of pollution caused by traffic. And in our region, so Flanders, the northern part of Belgium, we have 60 reference stations that measure these NO2 concentrations. And to see whether we comply with the European Union norms. But we also know that the air quality varies a lot. So it varies from street to street, from neighborhood to neighborhood. So how do you calculate how many people are actually living in a place that exceeds these EU limits when the reference stations comply? Flanders uses a computer model for this, combining the reference data with meteorological data and traffic data to obtain these air quality maps. But we don't know how good these maps are. And this was a question that we wanted to answer. We wanted to know what the actual air quality was in Flanders. So we thought about techniques that we could use. So the first one we could think of was satellites, because they would be able to cover a much wider, broader area than the reference stations, but they also measure NO2 at a much bigger height. So the NO2 particles would be diluted over this whole height, and we would not know the concentrations in the lower meters that are actually relevant for our health. Then you could also expand the network of reference stations, but it would be very expensive, and it would not look pretty to have these green boxes in every street of in every neighborhood. So that's how we got to citizen science. So and including these citizens also gave us our project another main goal, to raise awareness about air quality among the general public in Flanders, and also raise awareness about what the average citizen can do themselves about air quality. So the project themselves, so the first one was organized in 2016 in the city of Antwerp with 2,000 locations. City of Antwerp is one of the biggest cities in Flanders. And then 2 years later, in 2018, we organized a similar project in the whole of Flanders with 20,000 locations. Both projects were organized with a similar timeline. So the project was launched in the beginning of March, and the citizens had 3 weeks to register themselves as a measuring point. And this was combined with an extensive marketing campaign and extensive recruitment campaign. Then after the 3 weeks, we selected the most relevant locations for us. We distributed the measuring packages. And then in 4 weeks of May, the citizens used these tubes to measure the NO2 concentrations in their street. over the summer, these tubes were analyzed, and then in the fall, we had our communication about the results. So before starting with this project, we had to think about how to get thousands of non-scientists, average citizens to correctly measure the air quality. So a method to measure air quality that can be very correct with a lot of high quality data would be a smart kit, but we did not want to use this because we thought if we use these highly technological solutions, we can only speak to an audience of smart citizens that are already invested or people that already are interested in using these technologies, or people that are already invested in the problem of air quality, which would mean we would not reach as many people as we would want. So that's why we looked for another solution, another sampling method, and we came to these tubes. So the citizens were asked to attach this V-shaped board to their street-facing window on the first floor. They only had to attach the tubes to this board and remove the caps at the beginning of the measuring period, and then put them back on at the end. This was a very easy to use sampling method. Of course, for another citizen science project, you will always have to balance ease of use with accuracy, because you also want to obtain very high quality data, so you can have your high quality publications in order to be able to convince policymakers to do something about your problem. So that's a balance you have to think about when setting up your citizen science project. So we have our sampling method that can be used by the average citizen, but how do we convince 20,000 of them to participate and pay even 10 euros to do so? So we set up a partnership with us, academia, here in the middle. We had help from a governmental institute, environmental institute, for the data collection and data analysis. And then we also, even more importantly, we had a media partner that helped us with the communication and campaigning. So it's called The Standard. It's one of the largest national newspapers in Belgium. So this media partner helped us make some clear choices about communication. First of all, the message that we wanted to carry out with our project. I think that's also very applicable for radon citizen science. So really think about what kind of message you want to carry out. You can go with a message that says, from a more scientific point of view, and really appeal to the rationality of the citizens, saying the concentration vary a lot. We vary from street to street or from area to area, and we need a critical number of sampling points in your area, so please join our project. You can also appeal to the moral duty of the citizen, saying it causes health effects, causes premature deaths, for example. I don't know details about radon, but for air pollution, this is definitely the case, and really appeal to the moral duty of the citizens. So we wanted for our project to stay away from both of these and go more for an appeal to the emotion, appeal to the really call to action of the citizens, and say we're conducting the largest experiment ever on air quality. Do you want to join? And this is also the message we used in our following multimedia campaign. So we were very lucky with this media partner, because they had very professional designers that helped us with an extensive campaign in print media, in movie theaters, national radio and television, public domain, so on bus stops, on buses, we had these advertisements. We had several social media accounts on Facebook, Twitter, and so on. We also had some famous Belgian people that acted as ambassadors and participated in our project. This was all I think we can say this was very successful, because one of the first results I want to tell you about was even before we started our measuring campaign. It was already with the registration. So after 3 weeks, we hoped to reach 20,000 people, but we had almost 53,000 registrations, mostly families, but also school, local governments, so municipalities, companies and organizations. This was very positive for us because we both had our one goal of reaching as many people as possible. We obtained this goal, but we also could have we could also select the most interesting locations for us scientifically. So both was for both goals very positive to have so many registrations. Then after the measuring campaign, this was one of the main tools we used to communicate to the broad public. So this was a map of Flanders with each measuring point represented by a dot, and the color of the dots represents the air quality, ranging from blue to green to yellow to red to black. If you can count very fast and very accurately, you will see that there are no 20,000 dots on this map, but only 19,000. So even if you choose a very easy method, you will still have some people doing something wrong. For example, in our project, we had some people who did not remove the caps from their tubes, so they did not accumulate any nitrogen dioxide. And we also had some people who didn't stick to the 4 weeks of measurement, so we could not compare their measuring point to the others, and so on. So really something to think about, what everything that can go wrong during your with your measurements. Then another results were the hotspots that we found in Flanders. So we expected a lot of urban hotspots, but we also found some rural NO2 hotspots, and they were almost always linked to traffic and urban planning. So in these green, blue, so areas with a good air quality, we still saw sometimes a couple of red dots, and we always, or almost always, saw that was linked to a poorly regulated traffic light with a lot of stop and go traffic. Then we also saw a big difference between villages with a central crossroad and villages with a ring road. So with a central crossroad, we see that all the traffic goes through this central point instead of dividing all the traffic over the different entry and exit roads. Another thing we see with the central crossroads is that we also have buildings enclosing this central point, because you are in the center, so creating a street canyon and accumulating the NO2. Then lastly, one remarkable result we obtained with a survey that we did a year later. So we asked the participants whether they would move or had plans to move based on their air quality results, and 6% of participants indicated yes. So that's really, really a lot. So there's a lot more I could tell you about our project, but I don't have the time today.
Thank you, Dr. Allonsius. So Camille Allonsius, she talked about this for air pollution. So now we'll move to radon with Stephanie Long. Stephanie has a background in physics and radiation protection and is the manager of the EPA's radon and citizen science programs. Mrs. Long will give an overview of citizen science projects that have focused on radon testing and planned work on behavioral economics to increase testing rates. If you have specific questions for the speaker, just you can do this asking in the chat area. Thank you, Stephanie, the floor is yours.
Thanks, Mary, for the introduction, and good afternoon, everybody from Dublin. As Mary said, I'd like to just give you an overview of some of our radon projects that we could consider citizen science projects. First of all, I'd just like to give you a very brief snapshot of why radon is of so much concern to us. In Ireland, 500,000 people, that's about 10% of the population, we know live in homes that are above the reference level of 200, and we know that 300 people every year contract radon-related cancer. And we've been addressing this problem with radon in Ireland since the early 1990s, so for almost 30 years we've been working on this problem. In contrast to that, our citizen science project, our program began only about 3 years ago. And when we began this program, we spent a lot of time debating what should the definition of citizen science be for the EPA. And we agreed that absolutely it should be where members of the public collect data. And very much that the data has a purpose. So the data must be used for a research project, to develop policy, or perhaps be used by the community that collect the data. And we looked at ESCA's 10 principles of citizen science, and we try very much to incorporate those into our citizen science projects. And when we came to this definition of citizen science, we looked back and realized that many of the surveys we had carried out over 30 years to map radon and to understand radon better could be considered citizen science projects, because what we were doing was asking members of the public to collect data for us, and we're using that research, that data then, to carry out research, and then we're using the results of that research to communicate back to the public. So I'll just take you through a few of those surveys that we've carried out over those years. The first big project we carried out was during the 1990s. You can see it took 7 years to produce our national radon map. During those 7 years, we wrote to over 50,000 homeowners, and we did a lot of public awareness work also to encourage members of the public to participate. And you can see our overall participation rate was 21%. So 21% of those 53,000 homeowners we wrote to decided to do the test and also provide us with some information about how their house was structured and how they lived in their homes. So 21% participation rate back in the 1990s, when there wouldn't have been a lot of awareness about radon in the country. So we felt that was pretty good. So fast forwarding then to all the way to 2017, almost almost 30 years later, we decided to do another survey. We wanted to know what now was the updated national average indoor concentration. We felt it would likely to have been changed since the 1990s. And we did a study whereby we wrote to almost 4,000 homeowners in the grid squares that you can see outlined in black on the map on the right-hand side. And so those letters arrived to homeowners without any advertising or public awareness work. I suppose we felt there was good enough awareness that that wasn't necessary. And what we found, a remarkably similar response rate of 22%, a lot of variation from square to square, but overall we got the same response as we had from the survey we carried out in the 1990s. So fairly shortly after that, we carried out a related survey. In this survey, we wanted to know what was the population weighted average. And the reason we wanted this figure was to calculate the number of radon related lung cancers in Ireland. So to do this, we wrote to just under 6,000 homes. Again, in the grid squares, you can see on the map on the right-hand side, and you can see they're concentrated in Dublin on the east coast, where about a third of the population are. Again, we didn't do any public awareness work, and yet again, we got this 21% response rate, so remarkably consistent. Around the same time, we did a survey, a smaller survey in the west of Ireland. We wanted to see what would be the impact if we offered funding for remediation. So we wrote to 1,400 people, offering them a free radon test and up to €500 towards the cost of fixing their homes if they had a problem. That's about half of the cost of remediation. We also asked them to fill in a questionnaire about their home and about how they lived in the home. And again, there was no public awareness work involved. And we really thought, because of the €500 towards remediation, that this would make a big difference to the participation rate. But no, yet again, 20% was the response rate. So it seems as though it seems to be an upper limit on the response rate. It doesn't seem to matter whether we do public awareness work or not, whether there's financial support or not. So we thought we would have another go, and we decided to see, could we get above 20%? And we agreed last year to do a study with behavioural economists. And what we plan to do, and we should have completed the work by now, but it's been delayed because of COVID. But we plan to write to 4 groups of homeowners, 1,000 homeowners each. So there'll be 1 control and 3 different behaviourally informed letters. So each letter will be framed differently. Some will have local maps, some won't. And we'll see, is there any difference between the different groups, to see, can we in any way increase that uptake rate when we offer a free radon test? Now, all the testing in the world is to very little avail if homeowners choose not to reduce their exposure to radon when they know they have a problem. And this, I suppose, is the other side of the coin. We've known for a long time that where homeowners test and they find that their results in their home are above the reference level of 200, only 1 in 5 actually take some action to reduce their exposure to radon. And we've asked that a question. We've carried out a number of surveys where we've asked people that question. When you know that radon is a problem in your home, why would you not fix it? And there have been 2 main responses to that question. The first being people are very concerned about the cost. And secondly, they don't really think that there's a problem. They don't believe that radon is really an issue in their home. So the first issue, I suppose we felt the cost was probably a more significant issue. And that survey I mentioned back in 2018, where we offered €500 towards the cost of remediation, we felt, you know, I suppose we were just testing to see if there were a government grant available, what kind of uptake would there be? And you can see this inverted triangle summarizes that project nicely. Of the 1,400 invitations, we identified 9 homes above the reference level, and only 3 of those people chose to take that €500 to fix their homes. And we did work very hard to make sure it was very easy for the homeowners to get the €500. In fact, they didn't have to do anything. They had to contact a radon contractor, and the radon contractor filled out the paperwork. So, you know, we felt we removed as many barriers as we could, but in fact, in the end, having that financial support available didn't really seem to make that much difference. So looking at the other reason then for why homeowners tend not to fix their homes, they don't believe there's really a problem. So I have on the left hand side here is a typical EPA report, which is typically, there are many private companies also, but it's typical of a radon report that a homeowner would receive. And from talking to radon contractors, what they told us was that where they use a digital monitor, such as the Airthings monitor, that the response rate is far greater. So where a homeowner sees their radon concentrations in their home on a monitor, almost always they decide they want immediately to reduce their exposure to radon. So we felt there's something in this, and we thought, let's see if we can do a pilot project to see if we can use this, the effectiveness of the digital monitor to get people to take that very final step to remediate their homes. So we were inspired by a Canadian project that made digital monitors available through local libraries. And last year we partnered with a small library in the southeast of Ireland in a very high risk area. And we held an information evening in partnership with the library, like the librarians, and also with a local radon contractor. And it was a small project. We targeted people who had already done a 3-month test. So they knew they had a radon problem, but they hadn't taken action. And we persuaded them that it would be a good idea to take this digital monitor home, confirm, do they still have a problem? And if so, maybe that would persuade them to take that final step. And as I say, it was a small community library. The detectors have been, up until the lockdown, they were borrowed more than 40 times. And we know that 9 homes were remediated. So even in that small project, there was a greater number of remediations than when we had made a fairly significant amount of money available for remediation. There was no financial support here at all. So we've been speaking to the participants in the project, the people who use the library and took out the monitors in the way that they would take out a library book, to get some feedback from them about what was it that worked for them, what were the positives and what were the, you know, the things that could have been done better. And some of the key things were the fact that the library was local to them, that the information evening they found really useful and informative, the fact that there was a local contractor there and he was able to answer technical questions on the evening. The local librarians were brilliant. We spent some time with them, I suppose, I suppose just giving them a little bit of background information on radon. So they were able to answer a lot of the queries that people had when they dropped into the library. The fact that the monitor is so easy to use, there was no cost. We asked people how they felt having participated in the project, and peace of mind was the phrase that came up again and again. And another thing that was key about this project was word of mouth. So many people we spoke to said they had lent the monitor to a neighbour or to a family member, and that neighbour or family member had discovered they had a problem. So that community angle to it seemed to be really important. So I suppose just to conclude, I'd say it's a small project, but I do think that this type of small community-based local project, that there is potential, I think, to encourage people who know they have a radon problem just to take that final step to remediate their homes and reduce their exposure. So thank you for your attention.
Thanks, Stephanie. Thank you very much. So now we move on to another part of the world, Professor Konstantin Kovler. He's an engineer and professor at Technion, Israel Institute of Technology, and Taking Citizen Science to School Research Center. So Professor Kovler will explain the collaboration of the University of Haifa and Technion with schools with the approval of the Ministry of Education and municipalities to promote screening tests of radon by means of the Radon Test online system. So if you are ready, Professor Kovler, you can share your screen with us and unmute yourself. We cannot hear you, so if you can unmute your micro.
Unmute. Okay, done. Thank you very much for your introduction, Mary. Do you hear me well?
Yes, we can hear you very well. Thank you.
Okay, thank you very much. So I'm continuing the presentation of Stephanie, because we are both dealing with the implementation of citizen science approach in radon testing. So this is just one example of what we are doing together with Taking Citizen Science to School Research Center, which is a joint venture between our university, which is a leading polytechnical university in Israel, and University in Haifa. Let me continue. So we have professional challenges. I'm coming from civil engineering and measurements field, and we have also some challenges with citizen science. And this was an idea of coming to the team dealing with citizen science. I suppose Muki knows them. They're very active. They have a lot of publications, and they are serving as communicator with the schools, with Ministry of Education, because we cannot do everything by ourselves. It's an interdisciplinary project, and we have to do such cooperation. So professional challenges are following. So we are dealing with surveying, and to measure in mass radon, we need a lot of statistics. We need mass measurements. How to do it? And this is one of the reasons that we went to the schools. In principle, citizen science can be based on involving other professionals, for example, firemen or post office workers or other, let's say, communities, but we have some advantages of involving schools and school children. Unfortunately, we have so many professional challenges. For example, no unified strategy, test results are not exactly representative in these surveys, difficult to identify buildings with high radon and their share, and data collection is not automated. So yes, we have to face and we have to solve, let's say, these challenges. And from the viewpoint of the school children, what are their benefits? So, and let's say we have random sampling principle, because the schools are distributed all over the region, all over the country, in proportion to the population, which is a very important part of every survey. Attracting school children in the radon test in their homes solves both the first and second challenges, and additionally provides simple passive sampling and recording test conditions, information to the public about the radon problem. So we are improving the awareness of the population through the school children, through the parents, through the families, and so on and so on. And through the children, through the teachers, of course, and the administration of the schools. And of course, enhanced curriculum. What are the benefits for the schools and students? First of all, they have the results of the screening tests for free. Introduction to the science and technology course, which is a part of the curriculum in the schools. They are exposed to the lectures on radon, natural radioactivity, and other risk factors. By the way, if the school is interested, why we cannot help them to equip, and we are doing this, the school lab with simple and inexpensive detectors controlled by the special radon test online system, which I will explain in a minute. This is done thanks to the grant, generous support of European Commission, and with the help of taking citizen science to school center. Of course, I cannot personally, and the people from my team cannot personally speak with the school children and ask them to do this test. So we have, first of all, to get the permission from the high level, the Ministry of Education. And then, of course, we need to take care about privacy protection and all things we will discuss later. And we came to conclusions that without this powerful online system based on IoT solutions, we call it radon test online, we cannot move. So this is a very simple system, a global service system, cloud-based system, which is available 24/7. By the way, we are doing this survey using the cheapest, maybe, and one of the popular, maybe the most popular in the US method, using charcoal. But of course, we can do with this system other sensors. We can use track detectors, electrics, continuous monitors, and so on. What is interesting, this system creates online database and radon map with automatic geolocation. And this is very user-friendly system. So even school children can easily test radon in their homes. This is very simple equipment, a detector. Here, detector and the charcoal flacon, small bottle. You can try. You can try scan this barcode. We are distributing these sensors among the school children, providing this barcode. So if you like, you can try. I'm speaking with you, with attendees of this webinar. I will wait for 3-5 seconds. If not, I will demonstrate by video how it's working. It's very simple. When you scan, because everybody now, even every school children have their own mobile phone, so this is not a big deal for them. They can scan immediately what we are distributing. And then please enter the sample number 1, and then you will have automatically opening the menu with a guide to sampling, explaining where to put this bottle and what to do further. Before going to the test condition and results, I would like to make a new share and show you some video we prepared yesterday. So it will go very fast because speed is 1.5. So let's say my student gets this bottle. First of all, we need to prepare this bottle. We need to fill with a dry and prepared charcoal. We need to weigh, because the weight is important. We need to compare the weight before and after the test, because it's absorbing everything. The charcoal is very good absorbent, CO2 and other gases, including water vapor. Then we get back this, let's say, this bottle, or it's done by the student, for example. Then the student get this menu opening automatically. For example, the student name is Andrei, doesn't matter. And then we are asking the students to answer these very simple questions about the conditions, about the type of the building, about having ventilation system. And then they are starting. When they start, when they start, automatically geolocation is registered. So we know when and where the test started. Then we collect the samplers and continue to take care. So again, we need to weigh, we need to again scan it, and then the test is stopped. So when the test is stopped, then the test the sample is returned to us to the lab. We have to wait again, and then we are trying to measure in the lab. So by using this ionization chamber, it's very simple. So by the way, I would like to show you how it works. So we can measure in parallel channels several samples just to economize the time, because every test in the laboratory takes half an hour or something like this, or maybe more. And then we are putting the results in the database. You can see we divide between different levels. And then, of course, it's not surprising for us, because most of the buildings, most of the premises have, let's say, relatively low concentrations. So as we know well from the literature, from the surveys, the distribution of radon at homes is log normal. Then I continue. And then we are putting the results here, and then we are sending the results by email to the participants. So when we click on this envelope, the results are sent automatically to the participants, Okay, so going quickly. And then look, the student has the announcement by email. So this is only the personal data we need, because we have to inform the participant, the student, the school child about the results. Name is not needed, by the way. We are satisfied with nickname, only the email address, and that's all. And then we provide the results of this screening test in becquerel per cubic meter. Of course, it's something very unusual, because we recommend minimum 3 days. The best results will be between 3 and 6 days. Everything is written in the guide. And then what is interesting, we have automatically built map, radon map. Look here, for example. Every student can find him, herself by indicating the location. Of course, we need to protect the privacy. So please, pay attention that the circle we are using for indicating the results on map is relatively big. It's minimum 120 meters. Otherwise, the address will be known for everybody. So it's a kind of protection. But this is a map which is seen by the participants, not by us. Of course, we as experts, we know everything, but we guarantee that these data are kept in archive, and we do not publish them. By the way, I would like to invite everybody, including first of all the participants on RadoNorm project. We are offering to use our platform, which is already working for their purposes. The project starts in September, as I understand. You are very welcome.
Yeah, it started yesterday, Professor Kovler.
Started yesterday. So,
yes.
Okay,
thank you
good.
very much.
Okay, thank you very much. I think my time is over, and I'm stopping the share.
We can share your link afterwards or in the chat area with the participants. We will make sure that they get the information. And as announced by the chat moderator, because of time constraints, we will move directly onto the next presentation by Dr. Aaron Godarzi. So we cross the Atlantic, we go to Canada. Dr. Aaron Godarzi is assistant professor at Arnie Charbonneau Cancer Institute at the University of Calgary in Canada. And he will outline the Canadian experience of raising radon awareness, improving radon testing and mitigation uptake in the general population, and fueling interdisciplinary radon research using a citizen science-based approach. Thank you, Dr. Godarzi. The floor is yours now.
Thank you very much. So yes, I'm going to speak of our Canadian experience in using citizen science for radon testing, understanding how to engineer it away, and increasing mitigation uptake. So I'm a Canada Research Chair, and in Canada, these are federally appointed positions, and I'm the Canada Research Chair for Radiation Exposure Disease. So radon awareness and testing falls directly under our mandate. And the title of our project is Evict Radon, and this is something that we came out with as a very clear call to action. Evict, of course, is normally referring to something very bad from the place you live. And so we thought that was something that would resonate, and indeed it did. Our study commenced about 4 years ago. And in that time, we have convinced 52,000 people to radon test their properties, pay for it themselves. We do not offer free kits, although they are done at cost. We published 3 studies with 6 more on the way. We produced a lot of engagement, including real estate education courses. We've achieved new laws passing and others. If you're interested, you can visit the website, which is evictradon.org. And I will take you through a few highlights from that in the next few minutes. This is an alliance of university-based professors like myself at a variety of different universities in Canada, spanning our whole nation, which is a very large country and complex in order to do projects like this. We're interested in several things, and the purpose of the project is to not only understand exposure and prevention, but also we're looking at radon-induced cancer susceptibility amongst the population, as well as novel radon biomarkers. And so there's a lot of interdisciplinary science in what we do, and we've used a citizen scientist approach to that. And I'm going to highlight the things that I felt it was important to relay to this audience, which is defining a very clear call to action, explain how everybody can help very clearly, creating a very simple process. We've heard a little bit about that from others, getting the message out as widely as possible, supporting the participants, building trust with interesting science, and ensuring that the participants see the impact of their participation very quickly. And so the first, of course, thing that we do is we've built a fairly slick website. We hired multiple marketing and communications specialists in order to do this. And the first thing is to convince people that radon matters and they have to do something about it. Literally tell people why they should care and give them the information that they would need to understand that. And then literally tell them in the next thing what they should do about it in very clear and simple language. And doing that, we have achieved a great deal of success. And we provided a variety of other unbiased, scientifically referenced information where people can click on, for example, if they clicked on the radon exposure in children, get more information alongside the scientific references there. And collectively, because different people opt into the project for different reasons, people are convinced to join. We then make the journey extremely simple. This involves our own digital relations, outreach, media, getting people to the website, which is the most important thing there. They can make the decision to click consent and purchase their kit. Again, remember, they're purchasing their own kits here. Place, register, fill out our survey, they test, and then they return it and get their results again by direct email to them. What's important is to understand how people are hearing about the project. And what we found in this little pie chart there is that 63% of the participants actually decided to act because they'd heard about the project through the general media and media exposure of our own science. And what's important, again, in that graph is you can see how people really need to hear about it multiple times. In fact, a lot of people need to hear about it 3 to 10 times before they will actually do anything. So you have to get yourself out there repeatedly, which is why we do a great deal of media engagement on a whole variety of platforms, speaking about the science, speaking about the project, not just myself, but many others doing this across the nation. And it's through building that trust that's very important. We have kits that are very simple. We produced, I guess, what you would call IKEA-like instructions that are very simple for people to follow, even if their English language or French language use is somewhat limited. We do use the AlphaTrack long-term kits as we feel that's the gold standard for radon testing, and it's the most simple thing for people to do. What's really, really important, though, is to adhere to the best research ethics practice, get research ethics board approval. We always have that. Have very clear research ethics consent processes that people go through and we record. And of course, everything we do is with certified professionals overseeing the quality control. And speaking of that, this is how we're able to do really strong science, is because 5% of all participants are randomly selected for a no cost to them duplicate test, which is either placed 10 centimeters apart or in a different room, so we can understand the precision and also the accuracy, because we do a bunch of blanks and spikes and radon chambers, excuse me, in order to verify that the outcome of the data that we get is actually reliable. You must support and support and support your participants. It's amazing how people will get it wrong if left to their own devices. And so we provide step-by-step instructions on every single part of the process. They can go online and find that out at any given time. So if they want to know how to register, they would click on number 2 of this panel on the website. That would pull out a whole step-by-step process for them. And this is, I'm showing you the English here, but of course in Canada we're bilingual, and so we also do that in French. We have to really take time to ensure that everyone understands what participation can achieve. We're very clear and put on the website exactly what we do with their data and show the actual experiments and the outcomes for that, which ranges from promoting mitigation, understanding why certain properties have higher versus lower radon, our efforts to engineer out this from new houses, and a variety of other topics. And people can click on those and get more information based upon the science that we build. It's really important, I think, to ask engaging questions to capture people's attention. Although mapping radon is important, I would argue that it's even more important not to just map radon. For example, one of the big things we're doing is, again, understanding why different types of houses over time have had different levels of radon. Here you can show a graph showing one region versus another based on the property construction, and how the radon levels have really gone up in one region and gone down in another, and understanding why that is the case is extremely important. We have to go out into the community and keep people's attention through the whole process. This is ongoing. It doesn't just stop when people are testing their houses. In fact, it's most important whilst they're still testing their houses to keep doing this. To do that, we generate massive number of news stories that go out regularly, targeted to different regions and to different demographics. They can click on those. Here's one we did earlier this year when we were going out into the Canadian province of Saskatchewan, speaking about the research and encouraging local residents there to sign up. Of course, all of this, as we know and we've heard from others, it's essential that what you use the data you get for is for peer-reviewed and open access articles. We pay, of course, all the fees for open access, as it's an obligation to our participants. Then we get it all professionally publicized. And because of that, we get a lot of media uptake across national television, radio, newsprint, and other platforms. And that in itself promotes more people to sign up with us. And so the research gets more participants, which gets more research, and around it goes. Now, in terms of impact, we have a very good uptake in terms of convincing people to mitigate. Of the 19.5% of participants that have high radon, meaning greater than 200 becquerels, up to, I think we have 8,000 to 10,000 becquerel homes in our study. What we have is about 35% of those who need to already have mitigated, and another 53% express the intention to mitigate as soon as they either have time or money to do it. We have a very, very high uptake of mitigation, which has been a great success. And part of that I attribute to convincing people of the importance of the health consequences as well as the biology of this. And so finally, I will just refer again back to our website there that you can check out. I'll note a particular success in convincing legislators to pass new radon awareness and testing laws in Canada. And in terms of one of the more important things I spoke about, which is the research ethics approval, I'll flag an article we recently had published on this alongside the chairs of our research ethics boards, because research ethics boards often don't understand citizen science. And so we went through quite an interesting process with that, and we wrote this little article to reflect upon that. And thank you very much.
Thank you very much, Dr. Godarzi. We've seen so far all these great initiatives. We've listened to these great citizen science initiatives, first on air pollution, then on radon. Lots of issues are coming up, and I hope you can ask your questions in the chat area and later on during the discussion. And now we move to one of the main issues, which is also how to improve remediation. And for this, we have one of the experts, the main experts in France, Dr. Bernard Collignon, is engineer and senior scientist on radon risk at the Scientific and Technical Center for Building in France. And as I said, one of the main experts on radon remediation in Europe. So Dr. Collignon will talk about his experience as a professional in the field of remediation and the possibilities of citizens to remediate radon themselves or to have a professional to help them. So Dr. Collignon, the floor is yours. Thank you very much. You can unmute yourself and yeah. We cannot hear you. And you went very, very quickly through the presentation. So if you can go to the first slide, that would help. We cannot hear you. Bernard, you have to unmute yourself. We still cannot hear you. If you go to the bottom, and then it's unmute to the bottom of the screen, left bottom.
Maybe you can try by yourself to unmute him.
No.
Hello.
No, you're unmuted. Yes.
Could you hear
Perfect.
me?
Yes, we can
okay,
hear you.
I'm very sorry for that.
It's okay.
Can you see my screen?
Yes. Now, if you go to paramètres d'affichage, again,
okay,
it will work. We will see this presentation. Excellent. It works.
Thank you. Sorry for that. At first, I would like to thank the organizers for this of this conference to invite me, and well, I hope that experience I will present today will be of help to think about how to use citizen science in radon management. So I will present a French results of French campaigns, radon French campaigns in dwellings. We had this last year. So at first, French contest, you can see the radon potential map on your left, and which is the basis to define priority zones for the application of current regulation with a municipal mesh. Just to summarize the regulation of for existing buildings in priority zones, these priority zones, for some public buildings and working places, it is mandatory to undertake measurement and corrective actions when initial measurements are above 300 becquerel per cubic meter. But for dwellings, it is not mandatory to measure and less to undertake corrective action. The only thing who is mandatory is to inform new owners and tenants of dwellings that they are in priority zones. However, this for 10 years, many different radon measurement campaigns has been undertaken in France in priority zone, for example, in Brittany or in Limousin. And depending on the local possibility, these campaigns were organized It could be by in collaboration with the National Institute of Cancer, French Health Ministry, French Nuclear Safety Authority, regional health agency, or consumer and professional associations. In addition to that, because there are many different initiatives, French Health Ministry decided to develop a kit with technical and organizational tools to help to implement this such kind of campaign. These tools were developed by CSTB. First step of such kind of campaign had the objective to raise public awareness and to encourage building protection, to develop information towards the population and professionals, to encourage professionals to develop skills in relation to a field demand, and also to organize the feedback for the analysis of potential links between indoor radon levels and building characteristics. So the method was to develop information campaign for the distribution of free passive detectors. Also, for sure, to distribute such passive detectors, and also a questionnaire describing the building. And as a return to organize local meetings of restitution of information for the population and the professionals. And the idea, one of the ideas was to for us was at a scientific and management level to capitalize feedback on initial measurement levels compared to building characteristics. So just as an example of results we have in such domain, you can see because we have some building characteristic and information referring to changing windows or installing thermal insulation or modifying airing of the building. So we consider if we have one of these three characteristics, we were in front of a retrofitted building. And we compared in the, on your left, in the sample of more than 3,000 dwellings, which were retrofitted and other which were not retrofitted. And the same in another sample in Limousin, the center of France. And you can see the impact of retrofitted building on the average indoor radon levels. And if you are interested in it, there is a publication on this results. And the second step, which I hope it is of interest today, it was developed in a coordination between a local association, Approche Ecohabitat in Brittany, and CSTB, and funded by a local health agency of Brittany. And the objectives were to analyze the motivations of the population to undertake at first measurements, but also to protect building and to control the efficiency of corrective actions. The idea was also to propose technical assistance for the implementation of corrective action, which were proposed by the association Approche Ecohabitat, and also to analyze the efficiency of the corrective actions implemented. So the method was to identify at first cases with initial radon concentrations above 300 becquerel per cubic meter. And it was based on we use a database from Brittany, which with several thousands of cases. We define a questionnaire to ask for motivation to participate to measurement campaigns, to design and implement corrective action, the type of corrective action, if they do it by himself or ask for professionals, and so on, different questions. And we organize the feedback and the analysis of all these results. So I'm sorry because I just received the results at the end of August. So it's very new for me, but I will just present you some feedbacks. And so we were able to send more than 600 questionnaire, and we have a feedback of 193 questionnaire, which is about a third of the questionnaire sent. So it was a very good feedback. And for the question on how the people know have the knowledge of campaigns, mainly it was through media, press, radio, television, and so on. And referring to motivation to undertake measurements, as you can see, it's an equilibrium between concern for health, need for information on radon levels, and a free dosimeter, and also the knowledge of presence of radon in the commune. Well, based on the 193 return, in this return, we have 91 return where people undertake corrective action, and 102 who doesn't undertake corrective action. And we can see that it could depend on the, when we calculate the average of initial measurements on the whole sample, it is more than 800. And for people who don't undertake corrective action, it is less than 700 becquerel per cubic meter. And you can see that people who undertake corrective action, the average initial level of the sample is more than 1,000 becquerel per cubic meter. So we can conclude that the initial level of radon in a dwelling is a motivation to undertake corrective action, for sure. Other results when when corrective action is implemented, you can see that quite more than 0.5% of cases it was completely or partly implemented by a building professional, and for do it himself it was a third of the sample. But we have 21% of no answer on this. For this question. And also an important point is that after corrective actions, we ask if they undertake control measurement, and you can see that in only in a third of the sample, we have a control measurement. It means that people install corrective action, but they are not interested to analyze the efficiency of corrective action mainly. And they are more interested in control measurement when the initial level of measurement is higher, as you can see on the right side of the table. And a last result is on the efficiency of corrective action. And we have only 29 cases where we have the initial level, the type of corrective action, and the final level, the control level. And so it enables to define an efficiency of corrective action. And we can see that the average efficiency of reduction is of 74% of reduction. And it is not so bad, in fact, when we compare to public buildings and so on. And you can see also that 69% of cases with control measurement are with a control measurement below 300 becquerel per cubic meter, and 31% of case with control measurement still above 300 becquerel per cubic meter. So I'm sorry because I had no time to analyze type of corrective action, because we have also question of type of corrective action. but I have no time to analyze and to present to you. And also other results I didn't present refers to the reason why people don't undertake corrective actions. And it is quite the same that Stephanie mentioned for Ireland. I mean, one of the reasons is the cost of corrective action. Another reason is that people don't think it's really a problem. And another reason could be that a lack of knowledge on corrective actions. And a temporary conclusion of this experience, we have quite successes in this campaign because it enables to ameliorate the knowledge of population referring to risk exposure to radon in priority zones, also to contribute to develop the interest of building professionals to improve their skill in front of emerging demand, and for us to ameliorate the knowledge of building on building typology and radon protection. And one of the results, interesting result, is that for cases analyzed, a relatively good efficiency of corrective actions is observed. Okay, I thank you for your attention.
Thank you very much, Dr. Collignan. You can see here examples of radon-free buildings, right?
Yeah, for sure.
This is a nice ending of your presentation. So
Thank
now
you.
that we had all these presentations, we move to the presentation of Dr. José Luis Gutiérrez Villanueva. He's currently the Secretary of the European Radon Association and member of the Executive Committee. He's working as a specialist on radon measurement, as a specialist radon measurement advisor at Radonova laboratories in Sweden. And Dr. Gutierrez will take a more critical standpoint. So we asked him to reflect a bit on the limitations of some of the ongoing citizen science initiatives for measurements and remediation without being the bad guy here in this seminar, in this consultation. So Jose Luis, when you're ready, you can unmute yourself and share the presentation.
Yes, here we go. Okay, can you hear me?
Yes, we can hear you and we can see your presentation. Thanks.
Okay, perfect. Thank you very much. Hi, everybody from Uppsala in Sweden. So good afternoon to all the participants in this meeting, and thank you very much to the organizers for the opportunity to provide a critical view on citizen science. As Michelle said, I am not the bad guy here, okay? So I am in very much favor of citizen science. But yeah, I would like to give a critical view, which is also important. First of all, I would like to start the presentation with the word risk. These days, we are all very well aware of the different risks. Mostly, the risk is coming from COVID-19, but we are also surrounded by many other risks. We can have traffic accidents, heart attack, fly accidents, earthquakes. So we have a lot of risks all around, all around us. And radon is another risk as well. Well, citizen science, when I was asked to give this presentation, the first thing I did was to Google, as everybody is doing nowadays, okay, what is citizen science? We hear a lot about citizen science and the definition looks pretty simple, but in my opinion, it is not. As the first speaker, Muki, said, citizen science is nothing new. There have been many experiences many years ago about in the 19th century, for instance, involving hundreds of members of the public to monitor different coastal locations. We have examples in meteorological research, citizens with meteorological stations providing data. But in my opinion, I think citizen science is a combination of many things. We have the public participation, we need the public, we need the citizens, and we need the citizens to collaborate with the scientific research. And also, we need the so-called amateur scientist. This is also very good, but we need to face the reality, and there are also risks, some risks involved when dealing with the citizens and trying to put citizens in connection with the science. We may have the situation, I hear from recently that, yeah, maybe some citizens can think, okay, let's take a vacuum cleaner at home shock the air, and with a Geiger counter, we can count what happens in the filter, and yeah, this is our radon level. And we will add this information to a website or whatever, and we have the radon level in our home. Of course, this is not good. So these things may happen. That's why I think it is very important that we have absolutely clear that we need the collaboration of many people in citizen science and radon. Of course, we need the scientists and we need the experts, because the expertise is really important when dealing with radon measurements and mitigations. But I will talk about mitigations a little bit later. We need the involvement of the authorities. Without them, we can do almost nothing. We need the citizens, of course, and we also need the private sector, the measurement services, the mitigation services. So it is a combination of everybody here. And I like very much the presentation by Camille, because it is a good example of collaboration of all the different actors involved on radon issues. But we need to keep in mind the common goal of everybody. Today, we are almost 100 participants in this meeting from different origins, authorities, private companies, researchers. But the common goal for all of us is to reduce the number of lung cancer cases attributable to radon exposure. I think we all agree that this is the goal of everybody. Problems. Yeah, as you know, in Europe, we have the directive GDPR, the Data Protection Directive. And this is a big issue when dealing with, not only with radon, but with data in Europe in general. You know, in Europe, we are 27 member states, and the degree of implementation of this directive is very different. So different countries, some of them, they follow a more strict approach, others a different approach, not so strict. So this is something that we need to consider. And this has some implications when dealing with radon. For instance, how to transfer the data, how to use private data, how to use data from the workplaces. So all of these things must be considered. And this is not easy. This is not straightforward. But in addition, we also have the European directive. This was absolutely a game changer on radon. I remember when I started to work with radon in 2002, some countries didn't have anything, any legal tool to enforce or to suggest people, okay, you need to measure radon. But now, since 2013, we have the European directive, and we have a clear reference level, 300 becquerel per meter cube. In Europe, we also have very strong institutions. We have regulatory authorities where they carried out a regulatory control on how to measure radon at the workplaces, at renting apartments, public buildings. We have very, very clear protocols in many countries across Europe about how to do radon measurements. In most cases, when there is a strict protocol done by the authorities, the measurements, they need to be accredited, ISO 17025. In addition to that, some European countries, they request extra technical expertise to carry out the radon measurements. But last but not least, this is something connected with the citizens, there are big gaps on radon awareness across Europe. You know that the countries with the longest tradition on radon measurements are probably the Nordic countries, UK, Ireland. They have done a lot of work, very good work over the years. And as more as we go to the south of Europe, the level of awareness among the general public, the citizens, people like our friends, people like our parents, in many cases, they haven't heard a word about radon at all. And we need to live with that. And this is a problem that we need to face. About measurements, a lot of work has been done in Europe over the years. And here in this table, you have some roughly estimations of number of measurements. We can start with Austria. This is a tiny country in the center of Europe with around 90,000 measurements. Finland, 300,000, Ireland, 80,000, Italy, 24,000, Norway, 200,000, Spain, 20,000, Sweden, probably more than 1 million measurements, UK more than 700,000 measurements. In most of these cases, most of the measurements are long-term, 2-3 month exposure by using passive detectors. Of course, short-term measurements are also used in Europe as well as continuous measurements. But again, I would like to remark that there are very, very clear protocols how to when to perform this type of measurements. But remember the first slides when I mentioned the word, our common goal to reduce the number of lung cancer cases that can be attributable to radon exposure. We can measure a lot and we can convince citizens and we can get citizens involved in our radon measurement projects. But if we don't remediate, all the efforts are absolutely worthless. So nothing will work. So we need to convince people that it is important to remediate. And to do that, we need the expert advice. The previous speaker, good friend, Bernard, he's one of the best experts, probably one of the best experts on radon remediation in Europe. So we need this advice to teach people how to do that. And we need to involve citizens in the remediation, and we need to provide examples of practices. I would say probably it's more important an example of bad practice than a good practice. What not to do when it comes to radon remediation, and of course also to radon prevention. And there is a lack of standards when it comes to radon remediation in Europe. As I mentioned before, we have a lot of standards, a lot of protocols, how to measure, but not so a lot about how to remediate. Some countries, they have registered remediation services like Ireland, but in many countries, it is not very clear what to do. And we have many questions from the citizens nowadays. Okay, what happens if I measure my home, my workplace, and the level is above the reference? There is nobody to help me to remediate my radon problem. So I think my 10 minutes come to the end. Thank you very much again. I am open to the questions from the other panelists, from the participants. And thank you very much, Michelle, and the organizers again of this interesting meeting. Thank you very much.
Thank you very much, Jose Luis. Thank you very much for all the good presentations. The first question, I don't know if you have questions to ask each other. I see that the chat is quite active and you've been responding to the different questions by the attendees and also among yourselves. But one of the questions we would like to ask is what advice can you give us for the RadoNorm project that, you know, RadoNorm project started yesterday. So for developing a citizen science model on measuring radon and improving mitigation activities by citizens. So we have this 5-year project. We have some resources there to improve citizen science initiatives or to set up citizen science initiatives. What is the first thing you would advise us to do? So maybe it would be nice to go one by one. And the first person I have is already Jose Luis. So if you want to let us know what would be your advice.
Yeah, thank you, Michelle. If I am allowed, I would like to provide 2 advices instead of 1.
Yes, yes.
So you know me. So yeah, I was reflecting, about advice. I think it's important to be quite practical because many times we do a lot of philosophy, but we need to be practical because we want to involve the citizens on radon. So probably my first advice will be that we need to prepare videos. Nowadays, some people like, some people don't like, but a lot of people get the information coming from videos, from YouTube, Vimeo, or many other platforms. So it would be very good if the project create videos on how to test your home. I mean, there are many different providers of radon measurements across Europe. So take a few examples, how to do the radon measurement and what to do after that, how to do the remediation, get examples of experts on remediation. Maybe sometimes it's more complicated, sometimes it's much easier, and just some videos like 2-3 minutes, and this will be very useful. This is my first advice. My second advice, I took a little bit experience from Ireland. I mean, I spent there a very nice time in the past, many years ago. And I mean, they did something very interesting, the road SOSH. Maybe Stephanie can talk a little bit more about that. So EPI Ireland, RPII on that time, they were doing road SOSH in different places across the country. And maybe in Europe, authorities can do the same. Just go to the supermarket, for instance, or a big shopping mall, set up your stand there, and okay, this is radon in a very simple language with some materials to provide to the population. And yeah, this is radon. We are here in this shopping mall. We are in a high risk radon area, and this is how you can test your home. And if something is wrong, this is how you can remediate your home. And maybe with the use of the videos, project the video at the same time. So we need to make things easier for the citizens to show the citizens that radon is everywhere. And radon can be measured, can be tested, and can be mitigated as well. So this will be my two advices.
Thank you, Jose Luis. So maybe Bernard, as a radon mitigation specialist, you can let us know if you see this approach feasible, or what are your recommendations, your advice? Thanks.
Well, in the same way as Jose mentioned, I think it's very important to facilitate the access to information for people. And the first point is the risk assessment consideration, because most of the people don't consider there is a real risk because you can't feel it and so on, and you have other problem in life. So it's very difficult to convince people that there is a risk. So it's always necessary, could be video or other things, but to try to convince people that there is a risk, and also to facilitate the access to information for measurement. It's quite easy, but also, as Jose said, for remediation, because we know what to do, but it is very complicated to spread this information to public and also to building professionals. So it's another problem. And the second point is how to organize a feedback, because for us it's very important to be able to analyze. There is many things happen in different places, and it is always complicated to organize the feedback. So for me, it's a big challenge also.
Thanks a lot. Yeah, that's very useful, always to receive the evaluation and feedback. So Stephanie, maybe because Jose Luis mentioned that the road shows that you've used in Ireland, maybe you can tell us a little bit more about this.
Sure. It's probably a little easier to do road shows in Ireland because it's quite a small country, so we would have had road shows which would be maybe a week-long campaign where we would choose an area that is high risk, and we would have public meetings in the main towns in those areas, and we would invite the local authorities. Usually the mayor of the town would come, and we would have information on local radio. And you know, we usually, it depended on the weather and what else was happening, but you know, sometimes we got good attendance, sometimes not so good attendance. But I suppose it was really important that we were able to visit local communities and not be sitting in our offices in Dublin, you know, telling people what to do. And having said that, it's very resource intensive. Even in a small country like Ireland, you know, we might be 1 month preparing for a 1-week campaign, but it's very effective. And actually, and there are other ways of connecting with local communities. For example, if there are big exhibitions, so for example, every January, there is an exhibition it's called the Young Scientists. So a lot of schools do science competitions, and thousands of people visit that exhibition every January. So we have a stand there. Normally in September, it's the biggest outdoor event in Europe. There's a competition. It's an agricultural event, but everybody, you know, hundreds of thousands of people attend it, and we always have a stand there. So if you can find events where you get a big footfall and have a stand, it's amazing the number of people who want to talk to you about radon, even at events that wouldn't seem related. José's point really was very connected to the point that I wanted to make, which is involving local stakeholders. I suppose what we found is meeting communities has been important, but also including whether it's local politicians, the librarians, for example, local contractors. So that there's somebody on the ground locally that people can connect into. I think that has a big impact also.
Thank you very much, Stephanie. You have a lot of experience on that, so that's very useful. So maybe Konstantin, Professor Kovler, you can let us know what would be your advice for RadoNorm. You already offered us to collaborate and see.
Yeah, you're welcome, because we are doing this. Let's say our approach is working well, but we had some short discussion in chat with Jose. You're welcome to read our comments. Yes, I completely agree with Jose, because in Europe we need accreditation for providing the results, which has a, let's say, a justification, and which can be discussed in the court if you like. So there should be some weight, some professional weight behind the results. When we are using this citizen science approach, of course, our citizens are not professionals. But in our opinion, there is certainly a room for involving citizens like school children in mass measurements of radon, because we are limiting this involvement by screening tests. And screening is a kind of preliminary indication. And this approach is well working in the US, because they have, I'm not speaking about citizen science. It's not our invention, of course. It was used in Italy many years ago. It was used in some other countries, also in the North America. But I'm speaking about two-action approach. The first level is getting the results after screening tests, short-term tests, which lasts a few days only. And then you can decide what to do. If you are not satisfied, please order the professional service and the expert from the accredited lab, or you can repeat the test if you like. So we can discuss different opportunities afterwards. But certainly citizen science, in our opinion, has a room for screening tests.
Okay, thank you very much, Professor Kovler. So maybe now we move to Aaron Godarzi. Dr. Godarzi, what would be your advice for RadoNorm after your great experience in Canada?
So I think one of the most important things at the outset is we must consider the entire process from very first point of contact all the way through to not only convincing someone to mitigate if their radon's high, but emotional support for them, because some people react very badly to the outcome of their test. And then from a citizen scientist perspective, we have to be able to support those kind of reactions. So that, consider the whole process. And then the second major thing is hire a communications and marketing professional to help the scientists, not the citizen scientists, but the professional scientists, build a campaign that actually will resonate with the average citizen of your target region. And then you have to understand the different demographics within those regions. And unless you do that, we as scientists, I mean, we like to think of ourselves as great communicators, but most of the time we speak to our own colleagues or other scientists. And what we think might work actually is either inefficient, which is to say a lot of resources and a lot of time goes into not a lot of output, or actually ineffective or counterproductive. And so one of the best things that we did in Canada was liaise with professional marketers and communication specialists in order to do what we did for the least possible budget for the maximum possible output.
Thank you very much. This is very useful. And now we can move to Camille, who also shared her experience about air pollution. So not from the radon, but probably from citizen science, you have a lot to tell us, a lot of advice of what not to do and what to do.
Yeah, I think my advice really connects to the things Professor Godarzi already mentioned. So indeed, I think we look at the science too much, and we when we want to involve citizens, we really have to think about what's in it for them. So the average citizen will look at your project and think about what's in it for me, what will be interesting for me, what results can I use personally. So that's really something to take with you when you're organizing your project. They will not care about your high quality results and your high quality publications. And then something else I was thinking about, what we did with our project, we invited a journalist to our scientific meetings. So that's also about the communication with the citizens. So we invited her at our meetings so she could actually translate our project to a broader audience, and that really helped. So if you don't have money for a broad advertisement campaign, maybe this is still an option to invite this one person who can translate your results to understandable newspaper articles. And when you have this connection, this will also improve the quality of the articles. So it's not a journalist that just reads your press release and translates it themselves, but they can be active at the meetings and they know what has been going on. So that's good.
Thanks a lot. Thank you very much. So we have lots of challenges in front of us. So maybe we can move to Professor Haklay now, and you can give us your advice on what we can do.
So, yeah, so you had fantastic advices, and there is little to add to all these amazing suggestions. Think about it holistically. So that's something that came across in all these talks about not just to bring in the participants, the citizens, but also to bring in the scientists on board. Sometimes when they are more skeptical, they will feel more comfortable with starting with some more contributory approach. Frequently people come to me and ask for a co-created approach, but that's a bridge too far and it creates all sorts of complication. You need the knowledge how to do this type of thing. So it's actually, despite of this current excitement from everything co-created, I would kind of take different approaches to make sure that the scientists are on board, because otherwise they're like, you know, they will come up without why it's not going to work and how it's not going to work and how there will be problems. Some of the problems need to be thought of. Absolutely, the point that Jose raised are absolutely there. So the GDPR linked to what Aaron and I said about ethics and other things, but it's something that it's worth to think about. So holistically, and taking everyone, leaving no one behind, including the scientists.
Thank you very much. This is very useful. I don't know if someone else want to have a say now. If you have something that you want to share. Otherwise, we can maybe move to now Mandy, Dr. Mandy Birchwilks, because she is the RadoNorm representative in this webinar. So Mandy holds a PhD in biology. She was and is involved in a number of EC-funded projects, and among them, as I said, the RadoNorm, which started yesterday, and is a member of the coordination team and acts as the contact point. So she's substantially involved in the tasks to reach these targets that we've been talking about. So Mandy, maybe you can say some remarks from the RadoNorm project. Thank you. We cannot hear you, Mandy. Yes.
No?
Now we can hear you, yes.
Okay. Okay, thank you for that introduction and good afternoon to all that still listening. It's a great honor to be here today and to participate in this specific session of this event. I'm here and speaking on behalf of the RadoNorm coordinator, who cannot attend here due to other obligations. RadoNorm, you have heard this now several times and certainly wonder, what is this RadoNorm? In short, I can say RadoNorm is a multidisciplinary 5-year project, as you all already heard. It has been granted in total 18 million euros in the current FP7 Horizon 2020 and was launched just yesterday. RadoNorm itself aims to the significantly reduction of scientific, societal, and the technical uncertainties in all steps that we heard already of the radiation risk management cycle of radon and norm. That's why we are called RadoNorm, and thus contributing to a better management of the risk to human health and the environment. And in reference to the session we had in this afternoon, it is worth to mention that RadoNorm has dedicated from the beginning a whole work package to the societal aspects. And I should highlight here that in this work package, there's a task in which a network of citizen science projects will be established through an open call from RadoNorm. And I hope, or I think this will support citizen science activities addressing the mentioned RadoNorm testing, mitigation, and developing a radiation protection culture. And for this task, RadoNorm has earmarked 200,000 euro only for this particular task. And with the in the 7 talks we heard, we explored many potential for citizen science. And with the advice we received here, and this goes especially to the respected work package 6 now, RadoNorm looks to the future with confidence and is sure that with the tasks in this project, the public awareness of radon risk can be improved, as well as the collaboration between the experts and the society. So this is now in the hands of this work package 6 of RadoNorm. So let's do it.
Thank you very much, Mandy.
Thanks.
Thank you. Behind this work package, the work package leader is Tanya Perko. Most
Tanya
of you
Perko, yeah,
know her, and she is also behind the RICOMET sessions. So she's in charge of making this work, as well as Stephanie and myself as task leaders, in this case for the citizen science. And now we move on for the closing remarks to Olga, Dr. Olga Herman, Regulatory Standards Specialist at the IAEA. Thank you, Olga, for following all the sessions today, also on radon in the morning, on norm in the midday, and now in citizen science and radon in the afternoon. So you also want to mention Fukushima Dialogue Project, I understand.
Yes, thank you, Mary, for inviting me to this event. And yes, actually, as an advice, I mentioned to the RadoNorm project, I mentioned the Fukushima Dialogue Project, which was actually designed based on the dialogue of scientists and authorities with the local population affected by the accident in the Fukushima Daiichi nuclear power plant. And they didn't come as scientists and say, hey guys, now we want you to do this, this and that. But they came as scientists and talked to people asking, what are your problems? What would you like us to do? How do you think we should be doing it? And what do you expect as an outcome? And then based on these dialogues, small projects were designed, and the projects does not necessarily need to be measurement projects. These could be even economical projects, trying out different things. So it's just an advice to look at it and be brave. I don't say that all scientific projects need to be based on what the citizens need, but be brave to try it, to give it a try, because all what we do with radon is for the citizens. On the other hand, we should also sometimes keep in mind that On one hand, we are either experts on radon or on communication or social scientists, but on the other hand, we can always be citizens in any other scientific projects. So let's support each other, and if there are other colleagues asking and you see advertisements inviting us to become members of some project where they need support of citizens, we should definitely do it. So to conclude, I'd like to say that today I've heard presentations and it became obvious that there are many different definitions of and ways to involve citizens, and my personal understanding of what is a citizen science has broadened today. And I think there are many different potentials in developing tools, in developing measurement devices, in developing communication tools, remediation methods, etc. So I encourage all scientists to look for ideas among the citizens, and who knows what the most curious idea or extravagant idea can bring to science. Thank you all for your active participation today.
Thank you very much, Olga. So with this, we conclude this session of RICOMET. So thank you to all the speakers, again, high-level experts, and to all the participants and attendees who have been following the session, to the IAEA, to RadoNorm, to SHARE, to the RICOMET conference, particularly to Tanya Perko and to Stephanie Long, with whom we have designed this session, and for the time you have spent, to Joke for moderating the chat area, and for all your active contributions. As said, you can follow us on SHARE. You can see the video is being recorded, and it will be available next week, probably. Okay, continue, keep healthy, and thank you. Bye-bye.